molecule, benzene can be drawn using this first structure or the second one here. So at any point when I'm going to represent a benzene molecule, or in our discussions using either of these two structures, it just means the same, but the same thing. So in this case, the first structure, this is known as a Kekule structure. Kekule structure, while the second one is known as the Robinson structure. So whenever we come across these two different structures, so of course we shall be mentioning them. In any case, there's no need, then we shall be using one on behalf of another. So in this case, we are going to see also that there's a concept of resonance that we are going to learn about in this molecule, especially for the first one. Now, for the sake of representing it, because the second one, for it to visualize the concept of course, resonance, it's difficult but for the Kekule structure, it's going to be easier. So this particular kind of a structure, which we have called the Kekule structure, can as well be represented as this. So this double bond can relocate to this point, and then we have this. So that's where we're talking about the concept of resonance. And we're going to see that the benzene molecule can exhibit different resonance structures. And of course, benzene as a molecule is a resonance hybrid structure, which of course has been confirmed by experiments of X-ray diffraction. So benzene has been confirmed to be a resonance hybrid structure using the X-ray diffraction method. Of course, that's to do with the studying of bonds, bond lines, etc. So in this case, of course, the resonance structures are another form of representing the dots, the Lewis dot structure. Of course, we also talked about in one of our videos about the electronic dot notation for representing the molecules. For instance, we talked about hydrogen as having a single bond, but since it exists as a diatomic molecule, then we can be able to represent it there using that. So this one is representing the bonding in between the hydrogens, and this is a covalent bond, which means each of the hydrogen atom has donated one electron for them to form a bond and gain stability. So in this case, for the structure of benzene, we're also going to see that whenever it forms compounds, or it forms, of course, other structures or complex structures with other molecules, it's going to exhibit different characteristics, like the resonance that we have talked about. So for now, we're going to look at just an example or illustration of one of the resonance structures of a substituted benzene that we call aniline. Aniline is a substituted benzene that has got an amine group at one of the